Hey everyone, welcome back to my channel. Today we're going to talk about some pretty cool stuff. We're going to talk about some system calls. Specifically, we're going to talk about fork and exec. It's two very important ones. Um, so system calls are the API that the kernel exposes to user space programs. Um, what that means is it provides security for the operating system, and it provides abstraction for the user, or user space programs. So we can do system calls that uh, request resources or actions from the operating system. The three main categories that these system calls fall into are process management, signaling, and security. So the first one is the one we're going to talk about, process management. As a reminder, a process is just a running program. The operating system gives a process its own memory to mess around with. While a process is running, it can make system calls like fork and exec, which allow us to programmatically do really cool things with processes. So let me give you an example. I'm going to use C++ for this because it inherits from C the really easy way to make system calls. It just requires importing a C library. So first, let's make one process called first.cpp. We're going to include the relevant headers, which is IOStream for output to prove that what we're doing makes sense. And we're also going to include this header file that's also available in C, which includes some important system calls. Now, the first system call I'm going to talk about is fork. And this is how we use it. I'm going to explain what this means in a second. So when we call fork, the operating system actually does something really tricky. It creates a copy of the current running process with the same address space, like everything, all the variables are going to be the same. However, now that you have two running processes, if it was successful, we return 0 from fork in the child process, and we return the child's process ID, a positive number, in the parent process. So this if-else statement actually means that the code inside the first half will run inside the child process, and the code inside the second half will run if there was an error or if we are inside the parent process. So what we can do is say hello from the child process. And we can also say hello from the parent process in this else block. Just return 0. And let's try compiling this. I'm gonna use G++. All right, so now that we've compiled it, let's try running it. That's awesome. You can see how it, it might look at first like we only have one thread of execution, but we're actually creating an entirely separate process with its own thread of execution, and we have a pretty clean way to detect which process we're in by querying the return value of fork. Now let's do something even more complicated that builds off of this. We're going to use the exec system call. Specifically, we're going to use exec v, which is a simplified version with less parameters. Basically, it allows us to pass in a string representing the path of a process we want to assume. And I'm going to explain what assume means in a second. But for now, let's assume we have a process called second. And we don't need any other argument, so we're going to pass in an empty vector or array here. Now, to assume the process, by that I mean the operating system will replace all the data about the process that's currently running when you call exec with the data from the path, from the process located at the path that you pass in to the exec system call. So everything will be wiped out, and we're basically making a new process for ourselves. And believe it or not, this is how you should always, well, the most idiomatic way on Unix systems in general to start a different process from one process. First, you clone the process you're running with fork, and then you go inside the child scope and transform the child into the process you want by passing in the path. So to prove that this all checks out, I'm gonna make a second process, which is very straightforward. We're just gonna print out hello world, I think, or hello from the second process. Do a little smiley face because it's happy to be a running little process. um, we're also gonna compile this. Now let's compile the first one again and run it. Awesome. So it's a little glitchy because the first program exited and my command line updated with the next header before the second process was able to print to the standard out. However, you can see how first the child process prints out. At the same time, the parent process prints out that we're in the parent process. It takes a little bit of time to execute and replace all the memory in the child process with the data of the new process, and then it executes this code and prints out hello from the second process. So these are two very important system calls to know, and I'd recommend reading through the manual, the man pages, and doing some more research to learn more. I hope you have a great day.